Our next video lesson is on inscribed angles. We'll learn about inscribed angles and how to find their measures, an intercepted arc, and properties of inscribed angles. We'll also look at finding measurements of triangles and quadrilaterals inscribed in circles. Here's our definition. An inscribed angle is an angle whose vertex is on the circle, and the sides contain chords of the circle. Now, because we want it to look like an angle, we can extend the chord so it actually looks like an angle going through the circle. But the vertex, B right here, has to be on the circle to be inscribed. If it's at the center, remember it's called a central angle. The measure of the inscribed angle is exactly half the measure of what's called the intercepted arc. The intercepted arc is the piece of the circle that's inside of the angle, where the angle meets the circle itself. So here I have angle ABC is an inscribed angle, and the measure of angle ABC is 37.5 degrees because its arc is 75, and half of the arc, which is 37.5, is the angle measure. The central angle, just to do a comparison, is also 75 degrees. So this is central, this is inscribed. Here's an example. If the measure of the inscribed angle is 50 degrees, to get the measure of the arc, the piece right here, we're going to do twice 50, which will make it 100 degrees. If we have the arc given as 40 degrees, the measure of the angle, angle BAC, is going to be half the measure of the arc. 20 degrees is half of 40. Here's a general rule. If we have the measure of the arc as a semicircle, 180 degrees, then the inscribed angle, it will always be a right angle, because the inscribed angle is exactly half the measure, and half of 180 degrees is 90 degrees, which will make this always a right angle. Notice that the intercepted arc, this piece right here, makes a semicircle, and this segment would be a diameter of the circle. Here's an example using different types of inscribed angles. We can begin to see other shapes forming inside of the circle. Measure of ABE is the angle ABE. Here's our angle. This would be 1/2 the measure of the intercepted arc, which is 80, which makes the angle half, or 40 degrees. Angle ACE, notice this angle here, ACE, also has the same intersected arc of 80 degrees, which makes the angle also 40 degrees. We want to find the intercepted arc of angle CAD. So we follow angle CAD. Its intercepted arc would be arc CD. We also want to find the intercepted arc of angle BAD. BAD has an intercepted arc from here to here, which is arc BD. Remember to name it. If it's a major arc, 3 letters, minor arc, 2 letters. Here we have a theorem. If a right triangle is inscribed in a circle, now we're looking at an actual shape inscribed, the hypotenuse would be a diameter if it's a right triangle, and AC, which is the length of the diameter, notice looks a lot like the other picture we looked at, which is its intercepted arc is going to be a semicircle, 180 degrees. But we can begin to start to look at shapes now inside of the circle. Here's another one. A quadrilateral can be inscribed in a circle if opposite angles are supplementary. So that means that angle D plus angle F equals 180 degrees. The measure of angle E plus the measure of angle G also has to equal 180 degrees. They don't have to equal each other. The sum just has to equal 180. Also remember that any four-sided shape has a sum of 360 degrees. All quadrilaterals have a sum of 360. What's interesting on this one is that each of these angles, DEF, for example, is an inscribed angle. So is angle EDG or angle FGD. When you're asked to find a measure or an intercepted arc, what oftentimes you should probably do is take your angle, let's say we want DEF, and know its intercepted arc, and extend the sides of your angle. That way you're able to see clearly where the angle is. So here's the angle. Now I can also clearly see where the intercepted arc is. So its intercepted arc would be, looks like a major arc, so we'd list it with three letters, arc D, G, F, for example. You can do that with any of the inscribed angles inside of the circle.